Let's get started then. Hi everyone, my name is Kyle Knapp, and I'm a software developer at Amazon Web Services, where I primarily focus on developing Python-based client-side tooling. So projects that I work on include the AWS CLI, the AWS SDK for Python, AWS Chalice, and a few other projects. So now that I've introduced myself, let's get started. The AWS command line interface, it's a unified CLI for managing your AWS resources and interacting with the various different AWS APIs. The AWS CLI was first launched in 2013, and year after year, we've been adding new features to the CLI. So if you're a current user of the AWS CLI, but haven't been keeping up with all the new features we've been adding, this is the talk for you. As today, I'm going to be going over some of the big features that we've launched in 2017, and by the end of the talk, hopefully you have a good set of features to come back with to improve your workflow for this year and the next. If you're brand new to using the AWS CLI, don't worry, you'll still get a lot out of the features I'm going to show, but I'm not going to go over a lot of the core concepts or the core use cases for using the AWS CLI. There's a session tomorrow. It's called Introduction to the AWS CLI. It's called DEV307. So if you want to learn more about that, I recommend going to that tomorrow. All right, let's get into the areas of improvements that we've made with the AWS CLI in 2017. The first area of improvement we've made is related to debugging. So we've made it a lot easier to understand what the CLI is doing under the hood and being able to go back in history and do some post-mortem debugging on your CLI commands. We've made improvements in terms of providing credentials. So there's multiple different ways you can provide credentials to CLI. We've expanded this by allowing you to do custom credential providers, and also expanded the ways you can assume roles. And finally, we've made some improvements to the Amazon S3 commands, specifically related to configuration, and I'll talk about that last. So let's go ahead and talk about debugging. So like I said before, we really improved the interface and the ability to go back and debug your CLI commands. But let's actually drive the motivation of why we care about this. There we go. OK, so if you've ever used a CLI before, one thing you may notice, it's like a black box. You input a command, the CLI runs, you get an output back. And for the most part, you don't actually know what is happening underneath the hood. And for the most part, you don't need to worry about it, because as long as you're getting the output you expected, it's a nice little abstraction to hide away all the specifics of making API requests, allowing you to focus on both the inputs and outputs. In the case, though, where you don't get an output you expected, or you get an error you didn't expect, it would be nice to go ahead and look under the hood of the AWS CLI to get a little more context of what may be going on. So if we were to actually go about and do this and kind of outline what specific information we'd care about, you would see a picture like this, where you have the AWS CLI. It's a wrapper around a lower-level library called Boto Core. And Boto Core is written in Python, and it powers the AWS SDK for Python, also known as Boto 3, as well as the AWS CLI. So if we were to go around and trace the command lifecycle when a command executes, you would see something like this. So the very first thing what happens when the CLI gets invoked, it parses the arguments out. So this event is important, especially if you're using bash. Sometimes bash parses it differently, and you actually see the actual arguments that get passed in. And then once the arguments get passed in, the next thing that will happen is the CLI will call Boto Core. So if you look at the Python code down below, you can see how the commands match up with the Boto Core client call. So you see the S3 API, and then you see also an S3 client. And then the list buckets command matches up with the list buckets method of the Boto Core client. And this method call is really going to do all the heavy lifting for us in making the API request. To continue on, the Boto Core will take these parameters and, using models internal to Boto Core, serialize it down to the HTTP request. And if we're following the command lifecycle, some information that we find useful include the endpoint URL, the HTTP method, the headers, the request body. And then to continue on, once the HTTP request is sent back, you'll get some information such as in the HTTP response, such as status code. So if it was successful or not, you get some headers so you can identify what the request is if you're going through support. And you'd also get what came back over the wire through the HTTP response body. Afterwards, what happens is Botocore will use the same models they use to serialize the request to actually parse the response as well. And you notice at the bottom that this is JSON. This got parsed from the previous XML body that came over the wire. And with this parsed response, it returns it back to the CLI. The CLI will then determine if it was successful or not. In this case, we were, and exit with a return code of 0 and print out the actual output from the parsed response. So this interface, or this display, is very convenient if you wanted to get that contextual overview of what a CLI command is doing. But if you remember when I first started, you don't really have that prior to this year. The CLI is essentially a black box. And really the only option in order to go ahead and open the black box was to use the -s debug flag. And with the -s debug flag, what it gives you is it gives you a bunch of logs related to specific events. It encompasses all these events that I have displayed here in the diagram. But there's a lot of specific events that only developers of the CLI like myself are concerned about because we already know the ins and outs of the CLI. So having a nice overview like this would be ideal. So to get into a demo, let's go ahead and talk about this feature. Cool. Can everyone see that? Cool. So for this demo, what I'm going to do is I'm going to use an AWS service. The specific service is AWS Code Commit. AWS Code Commit is a fully managed source control service for hosting secure and highly scalable Git repositories. And in my workspace, I have my repo already cloned down. If I look inside of my repo, there's just a README. So it's pretty bare bones, and ideally, we'd want to add a little bit more to it. So specifically, what I'm adding is a license. So I have a license branch checked out here. And if I do a git diff of this recent commit, you'll see in the license there's Apache 2. And now let's say we were coding with our fellow developer. We're on a development team, so we can't merge this directly into master right now. We have to get it through code review. AWS Code Commit launched recently the ability to send pull requests. So we're going to use the AWS CLI to create a pull request and show how we can debug through the new feature of the CLI. Before starting, I'm going to go ahead and push up this branch to my remote. All right, so now that it's all pushed up, let's go ahead and run the AWS Code Commit create pull request command. So in order to do that, we're going to type in create pull request, give it a title, call it adding a license. And then we're going to give it targets. So in the targets, we have to specify a repository name. The name of our repository is repo name, or my repo. We have to give it a source reference. So this is the branch we're trying to merge. The source branch is license, and we have to give it a destination reference. So this is just going to be the master, because we want to merge it into master. And from there, one more thing we want to add is a description. So you usually want to give a little bit of context of why you want this code to get merged. So we're going to go ahead and run it with description. And I really don't want to get, so for this pull request, I really don't want to get into how Apache 2 works. So instead, what I'm going to do is go ahead and copy the Wikipedia link for if they're interested in learning more about Apache 2 and use it as the description. So before I run this command, one thing I want to point out is I'm about to use a feature of the CLI where it allows you to pull the content from a remote URL. So whenever you provide the value prefixed with the HTTPS and just that, it will pull the contents from it. So if I didn't realize before and I ran this command, I would get an error like this. Whoops. I misspelled something real quick. Let me fix that real quick. Sorry. Cool. So I get an exception back saying that my description was over 10 kilobytes. That might be a little confusing at first. So mainly because I know that the description I provided was not that large, unless I realized that I was using that feature of the CLI. So I'm going to take the previous year's approach to actually debugging this if I wanted more context and use -s debug. And when I use --debug, I'll go ahead and pipe it into less a pager so I can see what the logs look like. And you can see here there's a bunch of different information about specific events that the CLI ran. And from these logs, you could figure out what went wrong. What I want to do now is actually use the new way to go ahead and debug these, and it's called AWS History commands. So if I open up AWS History, it's a service command under the AWS namespace. So the idea of history is you can actually record the commands you've ran in the past and be able to do queries on them, so you can see the specific events and see what commands you've ran. And in order to enable history, what you have to do is run configure set CLI history to enabled, so that sets it in your config file. So I'm going to go ahead and do that. And now I can rerun this command again. Now that history is enabled, it will record it, and it'll record that exception as well. So now one thing you may have noticed when I went to help, there's subcommands. I'm going to use the AWS history show command. And the AWS history show command essentially gives us that diagram that I showed before, where it has all the key events that we're interested in. I'm not going to get into the specifics of the values yet. I just kind of want to give a walkthrough of what exactly it gives you. So you can see the events of the arguments parsed. You can see the API call made to Bodo core. And if you keep on going, you can go to the HTTP request that got sent over. So you see the URL it got sent, the post, all the headers. And you can keep going and see stuff like the response received and the response that got parsed. And finally, you'll be able to get the return code. So that's a nice little overview of exactly what the CLI is doing when executing that command. It gives you a lot of context about it. So from there, what I want to do is actually figure out what went wrong, right? So looking back at the HTTP response coming back, we'll see that we got the 400 status code, meaning a bad request. That indicates to me it must have been something I sent over the wire. Hence the error description. So I'm going to go back to the top and look at the parameters I sent over. And you can see based on the description, this is the exact value I expected. But now when you get to the Bodo core call, the parameters, and match up what the description was with what the value of the description you're passing in, you see a giant blob of HTML. And specifically, it looks like the contents of the Apache license for Wikipedia. And at that point, you realize you're using the feature of the CLI, and it's pulling the contents down, and hence why you're getting that exception coming back. So let's go ahead and actually fix this. And in order to fix it, we're going to not make the value just a single URL. We can just go ahead and put a little bit more words into it. So when I run this command now, I get a response back. And I can also use AWS history show to show that it was a successful request. So you can see the CLI command entered here. This is the description we added, and you can see now it got passed on to Bodo core correctly. And you can go farther down and see specifics about the request again. You can see that it got serialized into the body of the request, and also that we got a 200 response back, and all the relative information that we got from the parsed response. So you can see some of the information that you saw when I first ran the command. And of course, it exited with 0 because it was a success. Cool. So that was the first demo. The two things I hope you got out of this was the CLI history enabled mode. That makes it really convenient, so you don't have to provide --debug for every single command. You just type it in once in your config file, and from then on, it keeps a record of your history. And along top of that, the AWS history show gives you a nice detailed overview of what specifically your CLI command did when it ran. So from there, you can more easily debug exactly what happened. So now let's talk about the second command. When I talked about AWS history show, let's talk about AWS history list. In order to show off this command, I have this new directory right here and this bash script called clone. Don't worry if you don't know too much about bash. I'm going to walk through this with you. But essentially what the script's going to be doing is it will call AWS code commit list repositories to get on repositories. In a for loop, it'll take the repo name and call this clone function up top here. And in this clone function, it'll take the repo name and call it get repository. It'll query the clone URL SSH to go ahead and git clone it. So if I was to go ahead and run this now, you should start seeing that the repositories are getting cloned down. So it looks like it cloned one repository, and it's going to clone my second one I have available. And now when I list it all out, you can see the two directories that got created. So now what I'm going to do is use AWS History List to prove what I just walked through was correct in terms of explaining how the bash script worked. So here is the output for AWS History List. Each row is a specific command that you ran. And the far left column is a command ID associated to each command. So another feature of AWS History Show is that if you add the command ID after the show command, you can get the events for that specific command you ran. On the next column, you'll see the date time that the command got ran, the command specifically that got ran, and also the RC as well. So we were both successful in all the Git repository commands we ran. So looking into the actual script, we can actually see what commands got called. So we see how the list repositories got called, and then subsequently 2 Git repositories got called. But now let's go ahead and actually look at one of these to see what exactly is going on. So I'm going to run AWS History Show. And you can see immediately what repository got called for this command. So you see how the myrepo parameter got mapped into the repository name. And if you continue on and go to the bottom, you can also see the clone URL that we use to clone the repositories. So specifically, we use this value right here. So that is nice, so you can have a nice overview of exactly what a bash script does if you need that extra debugging. It also is very useful if you have a bug in your script and you're trying to figure out what the heck went wrong. So what I'm going to do now is actually go into my clone script and mess something up. Say I was working on it, and I messed up the James path expression to query out the repository name. Say I remove the I right here. And let's see what happens when I run this the clone script again. I get the error back saying the repository does not exist. A few things may confuse me at the start. One is saying that none doesn't exist. Not really sure exactly what none references. Is this a repository name? Is it actually just missing? There's not a lot of context in terms of how I wrote the bash script. So this is where AWS History List comes in to actually go ahead and debug it further. So I'm going to go ahead and run AWS History List to see what commands actually got ran. The first thing I'll notice, this is where we started, the code commit list repositories, but we only called Git repository once. If you remember before, we called it twice. So that's already something fishy. So I'm going to go ahead and take the command ID and run AWS History Show. So immediately you can figure out what exactly went wrong in terms of disambiguating the possible error cases. Specifically, you see the repository name that got passed in was none. And I do not have a repository named none. So that is what I would expect it to be in terms of getting that 400 back. So given that, let's figure out if the issue was with the list command, or list repositories command. So let's go ahead and copy down this command ID. And if we go on, what I'm specifically looking for is if we're getting the responses back that we would expect. So I want to make sure we're getting those 2 repositories. It looks like we are. And also, the parsed response looks correct as well. So that's telling me that there must be something wrong with how I'm gluing together the values from the list command to the Git repositories command. And in order to figure that out, I'm going to go ahead and reopen up the script and run that previous command to see what the exact James path query is going to be, or what the James path query results in. And you can see this results in none, which explains why we only had 1 Git repository called in the first place. So from there, we go ahead and look at the query. And looking really closely, looks like we misspelled repositories. We missed that I. And if we called it again, we get the correct response we expected back. So that's pretty much it for this demo. The things I hope you got out of this was the power of using AWS List and AWS Show together. Specifically, AWS List gives you a nice overview of the exact commands you ran. And in order to get more detail, you can go ahead and pipe the command ID to AWS History Show. Another thing that is very helpful is that when you have big scripts like this, the AWS History List command really lets you have a nice overview of what exactly ran, or if you have a job, say you had a cron job running a CLI command as well, and it failed randomly, you can actually go ahead and do some post-mortem debugging to see why it failed and have a better idea of what was going on, which is convenient as well. So if we go back to the slides now. Cool. That was it for this section. Specifically for debugging, what I covered was how you can enable CLI history with the CLI history configuration option, setting that's enabled so it keeps track of all the history commands, or all the CLI commands you ran over time. Then we have history show and history list to go ahead and peer into the exact commands you ran and the exact events via show and list. All right, so now that I covered the debugging improvements this year, let's talk about how we improved providing credentials to the CLI. So if you've used the AWS CLI before, you've probably used the AWS configure command where you get prompted for your access key, secret key, and you probably also know there's a bunch of different other ways you can provide credentials to the CLI. And as it relates to providing credentials, we've really expanded it by allowing you to provide your own custom providers and allowing you to expand the different ways you can assume roles with the AWS CLI. And to motivate this, let's go ahead and talk about the different ways you can provide credentials to the CLI. So there's the environment variables. You can do it through the shared credentials file. You can do it through shared config, ECS container credentials, or EC2 instance metadata. And the idea is when a CLI command gets ran, what happens is it queries the credential chain, and in the credential chain, it looks at each of these locations going from the top to the bottom to try to find the credentials. So if it's not in environment variables, it'll move down to the credentials file. If it's not there, it'll go down to the shared config, and if it finds it, it'll go ahead and return the AWS credentials back to you. And the CLI will then sign a request and send it over to AWS. So if I was to go ahead and replace it with some other SDK, any SDK has support for these credentials sources. However, the one thing prior to this year that other SDKs had on top of the CLI was the ability to provide their own custom providers. So the idea is if I'm using the AWS SDK for Python, I write my own Python custom credential provider, and I can plumb it into the credential chain so it gets resolved. However, this is the AWS CLI. In AWS CLI, the code base is locked. You can't import the code base in CLI and write your own credential chain and inject it. Instead, what we've done for 2017 is allowed you to do custom credential providers, but instead add a hook through the AWS config file. So let's go ahead and talk about this feature now. So this is a typical AWS shared config file, and the new configuration variable that we added was Credential Process. So the idea of Credential Process is it'll take that value and run it in a subprocess. And when the subprocess runs, it'll return credentials through standard out to the CLI to use. So let's go ahead and just show what exactly this looks like. So let's say the CLI ran this command with a profile dev. The CLI will know that there's a credential process set, and it's pointing to this script. So from there, it will go ahead and invoke the script will run, and return back this JSON payload through standard out. So when you're implementing your custom credential providers, there's a few things you need to take care of in following the protocol for this. So one, if you want to indicate success, you have to make sure you have an RC of 0. Another thing is you need to provide it as a JSON payload back. So specifically, you need to include the access key, secret key, a version number specifying what version of the protocol you're using. There's only one version, which is 1 right now. And given that, what will happen is the CLI will pull those credentials and use those to interact with AWS. So now let's go ahead and show how you can write your own custom credential provider using the AWS CLI. All right, so let's say that I'm a heavy user of my operating system's keychain. I like to store all my passwords, all my secrets inside of this keychain, and this applies to both my access key and secret keys as well. I don't want to be storing it on disk in the shared config file or shared credentials file. So in order to support this, I'm going to be trying to build a credential provider that accesses my credentials from the keychain. So to do this, I'm going to use the security command line tool. to go ahead and find a generic password in my keychain. And I have to specify the specific service I want. So I'm going to say demo access and use the correct keychain name. So to start, you'll notice that it prompts me for a password. So I'm going to go ahead and add my password in there. And it prints out a dummy value for my access key. And now I can go ahead and do the same thing for my secret. And you notice it prints out the secret key as well. So the idea now is let's use this command line tool. Let's create a bash script to go ahead and echo out a JSON payload that the CLI can then consume and use those for credentials. So in order to do this, I create a CLI alias. If you're not familiar with CLI aliases, it's very similar to Git aliases. So the idea is you write a shorthand command for a longer command. And you write these aliases in the AWS CLI alias file. And you can see this keychain alias that I have here. So for the value, what will happen is if I run AWS keychain, it will invoke this bash script right here. And specifically, what's going to happen is I'm going to use a find generic password command to store my access key, and then get my secret key the same way, and finally echo out this JSON payload back through standard out. So if I go ahead and run this, you can see this is the exact format that I need to use the custom credential provider. So let's go ahead and hook this up now to the AWS CLI. I'm going to be using the AWS configure command and setting the credential process to AWS keychain. And let's call it a different profile. I'm going to call it my keychain profile. So now I'm going to go ahead and run this. And now if I make an API call, let's say EC2 describe regions, what I should get is an auth error back because I'm using, whoops, didn't use the correct profile. Let me go ahead and change that. I'll get an auth error like this back because if I run AWS keychain again, these are the credentials I'm using right now. Secret key, access key, these are not valid credentials, obviously. So let's actually make this work. Let me go ahead and clear this to get back to the top. All right. Go back to the alias file. And then from there, I'm going to go ahead and replace demo with the word real, as I have my real access key and secret key stored in my keychain. And I'm going to do one more thing. I'm going to lock my keychain to show how you can actually prompt for the password in your function as well. So I'm going to go ahead and call lock keychain on my reinvent keychain. So now let's go ahead and rerun that command. And the first thing that should happen is I get prompted. So I'll go ahead and add my password. And what will happen is it'll use the credentials from the keychain to go ahead and call the EC2 describe regions. So that's the end of this demo. The things I hope you got out of it was really the flexibility of the credential process config variable. It really allows you to do your own, write your own custom provider if the CLI doesn't have a built-in solution out of the box for you. So there's no blockers for you to do that. So now let's go back to the slides and talk about another application of the credential process provider. So if you work for a larger organization, you're probably using an identity provider. So the idea is you provide a username and password to your IDP. And from there, you have authentication authorization to other services that you may require, so you don't have to keep typing your password or remember all the different passwords for all the different services. So in order to show how the workflow works for this, a user will first go ahead and send their username and password to the IDP. IDP will authenticate through LDAP identity store. And then from there, the identity provider will return a response back, specifically a SAML assertion. So SAML is an open standard for identity providers and service providers to communicate authentication and authorization, and it allows for features such as single sign-on. So the idea is that once the identity provider provides a SAML assertion back, the client can then use the SAML assertion to get credentials they may need. So this applies as well to AWS, right? So specifically for AWS, it's in terms of roles. So with the SAML assertion, the client will go ahead and call assume role to SAML using that SAML assertion To assume the role, you'll get temporary credentials back. And from there, you can go ahead and use those temporary credentials to interact with AWS. So fitting this all into the CLI now, the idea is we want to actually create a script so that when the CLI runs, it will invoke the script, the SAML workflow will go through, and we'll use the temporary credentials returned back. So let's go ahead and show how you go about doing this now. All right. So to get a better visualization of exactly how this workflow works, let's actually hop over to the browser, as the browser will give you a nice overview exactly of what the process is. So I have a Okta login endpoint set up. AWS supports many different SAML providers. For this case, I just decided to go with Okta. And the idea is I go ahead and type my username, and I type my password in. And go ahead and sign in. And when I get to this page, it'll show all the different services I can log in. So when I go ahead and click one of these, say the AWS one, it will take the SAML assertion and log into the console for me. So one thing I want to point out, if you can see there, is that I am now logged in with a SAML role as a federated user. And the reason I'm showing you this through the console is because it's going to be very similar on how we do it with the CLI, but we're just scripting it instead. So to help us with actually assuming roles of SAML, alongside the Credential Provider, we launched a new project called AWS Process Creds. It's under the AWS Labs repository, or AWS Labs organization. But the idea is this is a command line tool written in Python for providing different sources of credentials or custom credential providers. For now, all we have support is for SAML. So let's actually show how you can get started using this by hopping back into the command line. So the very first thing you can do is run pip install AWS Process Creds. I have it installed, but that will install it for you. And now from there, I have a CLI I can use to interact with SAML and get credentials that way. So if I type this and add SAML to it, let's go ahead into the help documentation real quick and see what the arguments you provide into this command line tool. So you provide the endpoint. So from the console, that was the SAML login page I was using. Then there's the username you provide when you first log in. You also have to specify what provider you're using. Out of the box, we support both Okta and ADFS. And then there's also the role ARN. So this is the role we want to assume with that SAML assertion. So let's go ahead and actually run a sample command. I have one of these saved already up front. So I'm going to go ahead and cat that out and go ahead and run it. And in order to better visualize what exactly it's doing, I'm going to use the -s verbose flag and pipe all that input into, or output into a pager such as less. So from now, the first thing that's going to happen, it's just very similar to the console where you have to type in your password. So I'm going to go ahead and do that real quick. So right now, it will show exactly what is going on with running this command line. So if you look at the very top, it first sends an HTTP post with my username and password directly to the Okta API endpoint. So from there, with that HTTP request now sent, it returns a response back to me. And you can see the SAML assertion that it received back. And you can notice that it's a big XML document with a bunch of information related to authentication and authorization. So you can scroll down through that and get to the next step, which was the assume role of SAML portion, right? So once we scroll down all the way, you can see that once we have the SAML assertion, we call SDS assume role of SAML. And in the parameters we provide to it include the principal arm. So this is the SAML provider we're using. There's the role arm. So if you remember from the console view, we assume the role through the assume SAML role. And also the SAML assertion. Note that is base 64 encoded. And at the very end, you see the credentials I got back. These are temporary credentials. So if you see, there's a session token and also an expiration. So these are temporary, so we can keep using these until these expire for us. And from there, let's go ahead and plug it into the AWS CLI. And to do that, let's go ahead and remove some of these arguments that we don't necessarily need and run AWS with a new profile, SAML, configure set. command. And now, once I set that, I can go ahead and call AWS EC2 describe regions and set my profile as SAML. And the very first thing that's going to happen is we're going to get prompted like before. Enter the password, and from there, it should go ahead and get the SAML assertion and then make the API request to describe regions. Another nice part about the command line tool that I'm using is it does caching. So remember, it has the expiration date. So what it does now is if it notices it has a potential response it could use, it loads it up, checks to see if it's expired, and if it isn't, it goes ahead and reuse it. So if I go ahead and run this command again, I'm not going to get prompted for my password. So that's really cool because it's similar to how the login experience for the console works, where you sign in once and you don't have to worry about it again. So that was the end of this demo. The key points I really hope you got out of it was to check out the AWS Process Creds command line tool. It's very helpful if you're currently using SAML in your workflow. Another thing also I wanted to point out was while this command line tool is written in Python, the nice part about the credential providers is that you don't have to be stuck using Python, unlike another SDK, where you can provide, I could have written this entire thing in Go, and as long as I have the JSON output that the CLI expects based off the protocol, it will work just fine. All right. So now that I talked about the credential provider, there's another portion of the improving the providing credential area that I want to talk about, which was related to assume roles and how we've really expanded that ability. So let's start talking about why we care about assuming roles, in the sense that when you first start out with AWS, it's very likely that you just have a single account with all your AWS resources in it. But as you expand out, you're probably going to want to break out into multiple different accounts, such as so, where you have the team accounts below the org accounts, and the reason why you want to break these out is that it gives you a nice sense of isolation. So members in one team account can't access resources in another team account. Furthermore, it allows you to audit billing per team better. And also, if you're using services like AWS Organizations, you can manage policies, and you can funnel bills straight to the root account or the org account in our case. And the reason why we want to care about assume roles in this case is because you can't actually use your credentials from one account to another. Instead, you have to use roles where you take your credentials and a role from another account and assume role to get temporary credentials to use and interact with those AWS resources. So in order to actually do this with the AWS CLI, you do it using the AWS config file. So you can see here I have two profiles, one for administrating my org account and another one for administrating my team account. So if I was to go ahead and run AWS S3 LS to list all my buckets in my team account, I would do such as this. And what happens is when it runs, it'll identify the profile I'm trying to run as. Notice there is a role arm. And with this role arm, it now needs to figure out what credentials it needs to assume the role. So it specifies a source profile, this admin org account, and notices that there are access keys and secret keys that it can use to then assume a role. And from there, you'll get temporary credentials that you can use to go ahead and list those buckets in the team account. All right, so now let's motivate the new feature that I want to talk about for this year. And it's related to the scenario where what happens if the team account wants to expand just like the org account did and add separate accounts for each project. If we had a structure like this and the org account wanted to access resources in the project account, ideally what would happen is the org account could just assume a role from the team account, and from the team account, you can assume a role for the project account to access those resources. However, prior to this year, the CLI only supported one hops for assume roles. So in order to get this working, the project account would have to give permissions to the org account to assume its role for administrating its resources. And with that being said, the feature that we launched this year is related to being able to do recursive assume roles, so do more than one. And specifically, you can see how the AWS config file got updated here with an admin project account. And now if I want to list my buckets in my project account, all I have to do is specify profile. And the process is very similar. What will happen is it'll identify there's a role to be assumed. It'll try to find credentials, and then next profile. Then from there, it notices it's another role arm, and it'll continue trying to find credentials until it stops. So it'll see that there's credentials here, and then it'll resolve this chain. So it'll take the access key and secret key to assume a role for the admin team account, and then it'll get temporary credentials to go ahead and assume a role with the project account to get the final temporary credentials to list those buckets in the project account. So this feature really allows you to be a lot more flexible in terms of how you administer roles and handle permissions, and it enables you a lot more of the CLI. To build on top of that, in terms of how you can assume roles of the CLI, one feature that I want to talk about specifically that I'm really excited that we launched this year was the ability to specify which credential source you want to actually go ahead and use to assume roles. Specifically, this example is related to EC2 instance metadata. So with Amazon EC2, you can store your credentials in instance metadata, so you don't have to store it on the box. Instead, you can query the instance metadata to go ahead and get temporary credentials to go ahead and make AWS API calls. But however, prior years with the AWS CLI, you always have to specify your credentials in the AWS config file, thus defeating the purpose of storing them in instance metadata, because in order to access resources in another account, you can only specify it via the config file. But with this year, what we've added is the credential source config variable. So the idea is that if we call the ls command with the profile admin team account, what will happen is we'll identify the role to assume as before, but instead, it'll notice there's a credential source, right? So from there, the CLI will access the EC2 instance metadata, get the temporary credentials to go ahead and assume that role and get temporary credentials to list all of those buckets. On top of that, likewise how we had other credential sources, the credential source supports those other ones as well. So we can swap this out for something like ECS container. So we can get credentials from the ECS container credentials. And also, you can do it from the environment as well. So that gives you a lot of flexibility there. And to wrap this all up, I'm going to go ahead and do another demo where I demonstrate how you can have this set up on your EC2 instance. All right. So let's go ahead and SSH onto this EC2 instance that I'm running. And on this box, let's first make sure we don't have any credentials stored in the config file. So if I do a cat real quick on the AWS config, you'll notice that there's just this profile specifying the role arm, the credential source. And to further the point, if I check the credentials file as well, that file doesn't even exist. So now I can still go ahead and make API calls because I'm querying the instance metadata for my default credentials. So let's go ahead and use AWS code commit again to list out our repositories. And as you can see below, these are the same repositories that I had from the first section, the my repo and other repo. So now let's go ahead and try to list the repositories for this account. And in order to do that, you notice that we have the role arm and the credential source being EC2 instance metadata. So use my default credentials to assume this role to list the code commit repositories. So let's go ahead and do that again. And this time, I'll just specify the profile as other account. And you can see when I run this that I have no repositories in this account. So you can see how it can access different resources based off the account. So to reiterate the usefulness of this, I was not storing any credentials on the box for EC2. On my EC2 instance, I was able to leverage the instance metadata to do cross-account resource access. So to wrap this all up, in terms of improvements related to providing credentials, I talked about how you can use the credential process to go ahead and plug in your own custom credential provider in the case that the CLI doesn't have what you need straight out of the box. I talked about how you can recursively assume roles via the source profile of the CLI in a case where you have multiple accounts you want to manage. And also talked about credential source, so specifying credentials outside of the config file to go ahead and assume the role. So that's especially useful for EC2 instance metadata. And finally, let's get to the last area improvement related to Amazon S3, specifically the S3 transfer commands. These are really, really useful commands. a lot of functionality, and you have a lot of configuration options available to you to get the performance that you want based off your environment. So to understand the configuration options, one of the things we added in 2017 is a new configuration option. So let's go ahead and talk about how the CLI commands work under the hood to understand how this new configuration option will work. So what I have here is AWS S3 CP. So I'm going to be doing a recursive download of the files stored in S3. And what happens first is each thread in this thread pool that the CLI has is allocated a get object for a specific object. So these threads in parallel will go ahead and call get object requests on these S3 objects, and they'll get a stream handle back. So once they get a response back, it'll go ahead and read from the stream chunk by chunk, adding to this IO queue. So each thread will keep on doing this. And at the other end of the IO queue, there is an IO thread pulling off the queue and writing it down to disk. And as it's writing to disk, the producer threads are still reading from the stream and going ahead and adding it to the IO queue. So as it relates to the configuration options for S3, it's specific to setting the options in the system. And in order to set these configuration options, you have to do it through the AWS config file. And previously of this year, there's only 4 options to use. And one specifically, what I want to talk about is max concurrent requests. So with max concurrent requests, the idea is that it directly reflects the number of threads being used. So in this current setup, I have a max concurrent request of 3 because there's 3 threads. And if I wanted to speed this up, I could go ahead and increase that number, say 4. So I have 4 threads making get object requests. So hopefully I get a little bit of speed up there. So going on, but now with the feature I want to talk about the opposite case where I don't want to be running it as fast as I can. I have a limited amount of bandwidth, and I don't want to flood my network. So in that case, an appropriate action would be to go ahead and lower the max request to something lower so there's less threads making get object requests. This is a good solution. However, there is the one portion that max concurrent request doesn't really handle, and that is the ability to throttle the reads of these streams. Right now, these threads are reading as fast as they possibly can and putting it onto the IO queue, so whatever resource allocation is granted to them. And specifically, the configuration option that we added is called max bandwidth. So it allows you to set the speed in which it's reading from these streams. So let's go ahead and demo what that specifically looks like. All right, so to reiterate, I'm still on my EC2 instance that I SSH'd onto. And on this EC2 instance, let's go ahead and cat that AWS config file again. And you notice there's no S3 configurations currently set up, right? So if I was to go ahead and download one of these files, whoops, typo. You'll start seeing this is about the max. You can see the bandwidth right here when it's transferring files. Over time, it ends up being about 45 megabytes per second. So let's take the case where I don't want to be using that much bandwidth in doing these transfers, right? I want to be able to use it for some other application. So in order to actually go ahead and decrease the amount of bandwidth, I'm going to decrease the amount of bandwidth I'm using. I can go ahead and set my max concurrent request to something lower. So let's wait for this to finish. And now I'm going to use the AWS configure command again to go ahead and set the max concurrent request to something low. Let's say, let's make it 1. Cool. So now if I cat the file again, you can see that max concurrent request is set to 1. And if I rerun this command, you'll notice that the transfer speed is definitely lower than where it was. And it's ending up being about 10 megabytes per second. That's still a little high for my taste. Ideally, let's say I want it to be 1 megabyte per second. So I'm going to Control-C out of this. And then I'm going to set the max bandwidth option. So the idea is I can go ahead and specify max bandwidth as well and specify the specific speed I want. So if I use a rate suffix, and I can set it to 1 megabyte per second. So now if I cat the file, it'll look like this now, where the max bandwidth is set to 1 megabyte per second. And if I rerun it, one thing you'll notice is it doesn't get to the speeds that we were seeing with the one thread. So setting the max concurrent request to something low and then using max bandwidth as well can be both very useful tools to get the desired speeds you want in the performance if the max concurrent request isn't doing it well enough for you. So with that now showed, let's continue back on the slides. All right, so that wraps up that section for Amazon S3, where I talked about how you can use max bandwidth to go ahead and set those the maximum transfer speed. For the demo, I only did downloads, but this also applies for uploads. So the idea is that when you provide a upload to S3, or we call it put object, you're providing a stream. So the same interface applies to uploads, where it throttles the rate in which S3 can read from that stream. So now that I've covered all the sections, let's go over a summary of what I covered. So first, I talked about debugging. So the idea is you can make it easier on yourself to understand how the CLI commands are running with the CLI history mode enabled, because it'll keep track of all the CLI commands they ran over time. There's also the AWS history show, so you can see specific events on how the CLI command got executed. There is also AWS history list, so you can see a list of all the commands got ran, and from there you can use the command IDs and pipe it into the AWS history show to see specifics for a specific command that you ran. I talked about how you expanded providing credentials, so using a credential process to go ahead and write your own custom provider by hooking it in with the credential process config variable, so the CLI will invoke that process to get credentials. I also talked about the source profile. So the ability to do multiple assume roles in order to get credentials to use with AWS, and also talked about credential source, so being able to specify credentials outside of your config file. Specifically, you can specify EC2 instance metadata. And finally, I talked about max bandwidth, where you can set it in order to ensure that the S3 commands won't exceed a specific bandwidth, and you can preserve your network that way. So now that I summarized all this, let's talk about what's next. And here is a list of helpful links that I'd recommend checking out after this talk. The first link is to the AWS CLI repository. So I'm bringing this up because a lot of the features that we develop with the CLI come straight from GitHub. These are requests from users of the CLI. So most of the features I talked about today were heavily requested via GitHub. So if you do have a feature request you want, go ahead and check out GitHub. See if there's an existing issue open for it, +1 it. If there isn't, go ahead and open an issue so we can start the conversation that way. The second link is to the process providers. So this is the link to the repository. Right now, we only have support for SAML, but as time goes on, we'll likely be adding more process providers, so have more options to hook into the CLI. The third link is related to the reinvent scripts. So the clone script and the alias. I'm going to be adding that to AWS CLI examples. Under there you'll see previous scripts from 2015, 2016. I'll be making a 2017 directory. And finally, the last link is a link to the AWS blog. I recommend following that as the year goes on. We'll be posting information about features that go out and any tips that come in handy in working with the AWS CLI. So with that being said, I thank you guys for coming. I really hope that you got a lot out of this. And if you're on Twitter and you want to follow, you can follow me. I'll be posting stuff about the CLI on and off. So if you're interested in that, I recommend you doing that. And I want to thank you guys all again for coming.